Lesson 1.5, Task 2. Compare functions given different representations. If two functions are presented using different representations, you may need to convert one or both of the functions to another representation before comparing properties. The function g is a vertical stretch by a factor of 2 of the parent absolute value function, followed by translation of 2 units left and 3 units up. The function f is an absolute value function represented by the table of values shown. Which function has the greater minimum value? All right, so we're given two functions. This one's verbal description. It's given to us in words. So g is a vertical stretch by a factor of 2, a translation of 2 units left and 3 units up. F of x is given in the table here. All right, method 1, use the given representations. The parent absolute value function has a vertex 0, 0. All right, so we know this. This is just a given because it's the parent function. It is an absolute value. It's a V-shaped graph with a vertex of 0, 0. And on the right side, it has a slope of 1. And on the left side, it has a slope of -1. That's just known because it's the parent function. All right, so which statement best describes how the vertical stretch of a parent absolute value function affects the vertex of g? Okay, so remember a vertical stretch would be your a value, so it makes it wider or narrower. So let's see what our choices are. The vertical stretch by a factor of 2 moves the vertex of the parent absolute value function to 2, 0 because the stretch moves along the vertical axis. Okay, so that's not true. The vertical stretch by a factor of 2 moves the vertex of the parent function. No. The vertical stretch by a factor of 2 does not move the vertex. That's true. All it does is make it wider or narrower. It doesn't move the vertex. So a vertical stretch by a factor of 2 does not move the vertex of the parent absolute value function because their y-coordinates are all 0. Okay, so that is true. All right, so it says translate 0, 0. Okay, that would be the vertex. Left 2 and up 3. All right, so if I move this left 2, that's -2, 3. So that would be this point here. So that would be the vertex of G. Your vertex comes from your H and K, which are your horizontal and vertical movements. All right, so the minimum value of G is 3. And that comes from the y value of your vertex. You know, you got a V-shaped graph, and your x is your horizontal, your y is your vertical. So your y would be your lowest point on the graph at your vertex. So the minimum value at G is 3, okay? And that comes straight from the y value of the vertex. All right, so it says, what is the vertex of F? It says, look at the pattern in the table. So f, remember, was our other function. And instead of giving us a verbal description or an equation, they give us a table. So we can see it goes -2, -1, 0, 2, 3. So they skip 1, okay? And it goes 7, 6, 5, 5, 6. So from here to here, these are reflections. So these are reflections, and these are reflections on the y. So your vertex is going to be right in the middle. So the one that's missing would be 1, x is 1, and it would probably be, since it's going down and then it goes back up, the lowest point, more than likely that's going to be a 4. So 1, 4, I would assume, is the vertex. So it says, what is the vertex? 1, 4, and that's based off the table. And then it says, so the minimum value of f is 4. And again, the vertex, the horizontal movement, so this is horizontal, this is vertical, this is off your y-axis, so this would be the lowest point. That would be your minimum, which would be at 4. So it says, comparing two minimum values, the function f has the greater minimum, okay? 4 is greater than 3. All right, so method 2, use a common representation. Since f is represented by a table, the given ordered pairs, x and f of x, which f of x is just y, so x and y can be plotted and used to draw its graph. To graph the function g, first create an equation using the verbal description. The function has a form g of x equals a, absolute value of x minus h plus k. All right, so this is just our general equation. And if we go back up to the verbal description, we can find our a, h, and k. So our vertical stretches are a, so that's 2. It's going to be 2 units left, so that's negative 2. If you move to the left, that's negative 2. And then 3 up. So 2, negative 2, and 3. All right. And then all you do with the a, h, and k is plug it into that general form. So you take a, h, and k from this equation and you plug in these values, and you can see that it's going to be 2 times the absolute value of x minus negative 2, and that's where it becomes plus 2. And then outside the absolute value is your vertical movement of plus 3, and that stays the same. All right, so if you want to look at the graph of f and g, f of x would be this absolute value function here. You can see that its vertex is at 1, 4, and this is our absolute value of g of x, and it is at negative 2, 3. So this one has a greater minimum because 4 is greater than 3. So that's two different ways to look at those two graphs. If you have any questions, please let me know. Lesson 1.5, Task 3. The ability to compare functions given different representations is helpful for comparing a variety of key features of real-world situations. Two teams are launching pumpkins. The height, h of a, in feet of Team A's pumpkin is given by the equation shown, where t is the time in seconds since launch. The height of Team B's pumpkin is shown by the graph. How do the maximum heights of the two teams' pumpkins compare? All right, so we're launching pumpkins. That sounds interesting, but let's look and see what we have. So Team A has an equation here for their pumpkin launch, and Team B has a graph for their pumpkin launch. So from the graph, you can see that the maximum height, here is the vertex, would be at this spot here. So if we look at our scale, we're going to go 40 to 60, so it'd be 40, 50, 60, 70. So we can see that this is about 70, I think it's in feet. Yes, 70 feet. All right, so we're going to have to use the equation to find the vertex from this quadratic equation. So let's see what it says. So it says use the given representations. Team A, the function is quadratic, so the maximum height occurs at its vertex. The vertex of a quadratic function in the form of f of x equals ax squared plus bx plus c occurs at x equals negative b over 2a. So this should be review. So all we're going to do is take our calculator and do negative b over 2a. So we need to know the function. So we're going to take our calculator here, and we've got a, b, and c. So negative b would be negative 56 divided by 2 times a, which is negative 16. And it doesn't like the way I typed it in. So let's do negative 56 divided by negative 32, because 16 times 2 is negative 32. All right, and that's 1.75. Let's see what that is as a fraction. If you hit math, fraction, 1.75 or 7/4. Okay? So we've got negative 7/4 or 7/4. All right, so 7/4 is our x. Now we need to find the y value. So we're going to do that by substituting 7/4 back into the equation. So if we have negative 16 times 7/4, and that's squared because it's quadratic, and then plus 56 times 7/4 again, and then plus 18. All right, so all I'm doing is taking this equation here that's given, and I'm just substituting the x value that we just found for that. All right, so that gives us 67 for our y value. If you remember, 67 is the highest or lowest point for that parabola. All right, so it says the maximum height reached by Team A's pumpkin is 67 feet. Team B, only an approximation of the maximum height can be made from the graph. The graph shows that a maximum height is approximately 70 feet. Team B's pumpkin reaches a greater height, or a greater maximum height. So 70 is greater than 67. All right, use a common representation. So if we want to look at a graph for each of these, this is what Team A's graph would look like. And you can see that it's just below 70, and this one actually goes up to right at 70. So even looking at a common representation, you can see that Team B has a greater height. So it says, can you visually determine a difference in the maximum height shown by the graph? And I'm going to say yes, you can, because this one is slightly lower than this one. If you're using the same scale, that's easy to see. All right, that's all for task 3. If you have any questions, let me know.